Hi, this instructional video is about the converse of a Pythagorean theorem. What are we talking about, converse? If you are given a squared plus b squared equals, in fact, does equal c squared, then this is a right triangle. If a squared plus b squared given happens to be greater than c squared, then this is an acute triangle. And if a squared plus b squared is less than c squared, this is considered an obtuse triangle. If it's greater than, it's an acute. If it's less than, obtuse. Greater than, acute. Less than, obtuse. Remember that condition. Now let's use that converse of a Pythagorean theorem and try to determine if these given set of numbers is in fact right, acute, or obtuse. So here's how it works. When you have your homework assignment, when they give you a series of numbers like this, the first number is in fact A, the B, and the last part is C. And it should always be the biggest number because that's the hypotenuse of a given triangle, the longest part. So we're going to use the Pythagorean theorem, a squared plus b squared equals a c squared. The a was given to you as a 4, so we go, that's 4 squared. B is 6, so that's 6 squared. And c is 8, so that's 8 squared. Evaluate, we get 16. 6 and 6 multiply becomes 36. 8 and 8 is 64. Add these two numbers, a squared and b squared, they become, what is that, 52? So does 52 in fact equal 64? No, it does not. So it's not a right triangle. But if you noticed, a squared and b squared, this is in fact less than 64. Less than the c squared. So this is considered an obtuse triangle. Yeah. So it's not a right triangle because they do not equal. But in fact, a squared plus b squared is less than the c squared. And we said the less than represents obtuse triangle. And that's how you define or identify the type of triangle given this dimension. So using that and using these conditions, why don't you try to determine what triangle 2 and 3 represent? All right, number 2. You said, okay, that's A, that's B, and that's a C. Plug it into the Pythagorean theorem, a squared plus b squared equals a c squared. A squared is 6 squared. B squared is 11 squared. C squared is 12 squared. 6 squared is 36. 11 squared we know, remember, is 121. And does that equal 12 squared, which is 144? Let's see. 36 plus 121 is 157. Does that equal 144? Obviously not. In fact, in this case, 157, the sum of a squared and b squared is greater than the c squared. And we said if the sum of a squared plus and b squared is greater than c squared, it's an acute triangle. Yeah. So how about this guy then? So you said this is A, this is B, and this is C. We're going to use the Pythagorean theorem again. A squared plus b squared equals c squared. A is 4 squared, b is 8 squared equals 9 is the c, so it's going to be squared. 4 squared is 16. 8 squared is 64. Does that equal 9 squared, which is 81? 16 plus 64 is going to be, close, but not quite, 81. So in this case, 80 is the sum of the a squared and b squared is less than c squared. This is, again, obtuse triangle. Did you see how that was done? All right, then. Why don't we try these questions and see if you get it all right on your own. Okay then. On number 4, 5, and 6, just like numbers 1, 2, and 3, we're going to use the Pythagorean Theorem, and we're going to use the converse to determine whether this is a right, acute, or an obtuse triangle. So in this case, again, this is A, this is the B I said, and this is the C. So we go A squared plus B squared equals a C squared. The A is 12, so that's 12 squared, plus the B is 9, so that's 9 squared, and C is 15, so 15 squared. Start evaluating. We got 12 squared, which is 144. 9 squared is 81. And does that equal 15 squared, which is 225? Hey, looking pretty good so far. 144 plus 81. Yes, in fact, it is 225. So since the sum of A squared and B squared equals 225, which is a C squared, this in fact is a dimension, the length of a size of a right triangle that is, like I just said, right triangle. And this one? So this is the A, this is the B, and this is the C. Again, A squared plus B squared equals a C squared. A squared is going to be 15 squared, B squared is 20 squared, and C squared is 25 squared. Now 15 squared I still remember as being 225. 20 squared is 2 times 2, which is 4, with 2 zeros. And 25 squared, I forgot again, so enter the calculator. So 25 squared, it says 625. So 625. Hey, what do you know? I got lucky again, I think. 225 plus 400 is in fact 625. So since the sum of A squared and B squared equals 625, which is a C squared, again, this represents a right triangle. And the last one, that's the A, that's the B, and that's a C. If you're taking a test, and if your teacher is giving you these kind of series of numbers to determine what kind of a triangle it is, oh, I think they would love you if you go and label it A, B, and C. And write each and every time the Pythagorean Theorem. And show that you are substituting each of the variables A with that given number 5 in this case. The B is given as 10, and C is given as 11. If you show this step over and over consistently, oh, you will impress that teacher. 5 squared is 25. 10 squared is 100. 11 squared, I remember, is being 121. Oh, not this time, because 25 plus 100 is 125. Does that equal 121? No, not this time. In fact, the sum of the A squared and B squared is greater than 121. And since we said if the A squared and B squared added together is greater than the C squared, it's an acute triangle. So this is acute. There you have it. I think we did enough practice to help you understand the concept of the converse of a Pythagorean theorem and how it's used. Good luck.